Welcome to your second lesson. You did some really heavy lifting in the last lesson where we learned all about the tangent ratio and we learned about how to do and undo angles to solve for angles. And now we're still going to use the tangent ratio, which is pretty sweet, but we're going to be using it to find something else. We're going to be looking at lengths of sides. So just from yesterday, or just from last lesson, remember that the tangent is a ratio of two lengths in a right angle triangle. Remember, it always has to have 90 degrees. And the tan of some angle, sometimes we use theta, or sometimes we use x or some other letter, okay? Tan of some angle is always going to be opposite over adjacent. In the last topic, we used side lengths to find angles in a triangle. Now we're going to be given an angle, and we're going to find the missing side. Now, we could use Pythagorean theorem sometimes, but especially in this one, we're noticing that we don't know two of the sides, so then we can't use Pythagorean theorem. If we just didn't know one side, we could. But so find the length side of AB. I'm just going to highlight it here so that we can really understand, so we know what it is. It's the length that runs between A and B. So I'm going to say this is our angle here. So 10 is our beside side, it's our adjacent. And then AB is going to be our opposite because it's the only side that doesn't make up the angle. Up. So I'm just going to set up my my tangent. Now it's going to be a little bit different because before we would have things like tan F and stuff like that, but instead we don't have, we actually have a value for it. So I can say tan of 30 equals, and I'm going to do something weird with the spacing here. That's why I'm kind of putting the equal sign a little bit lower. It's going to be opposite, which is our AB. And just to be consistent with colors, you know how I like colors. Over adjacent, which is 10. Now I'm going to teach you a little strategy, a mathematical strategy that is actually very practical and helpful in real life, and it's called cross multiplication. Okay, so I'm going to make two fractions. Remember, we can always make a fraction by putting something over 1. And what I'm going to do is we're going to cross multiply. So we're going to say on one side, it's going to be tan of 30 times 10. And on the other side, it's going to be AB times 1. Okay, so on this side, I'm going to say AB. And it doesn't matter which one it is. And actually, I'm not going to use times. I'm going to use brackets. Okay, because sometimes we have x's that are confused with multiplication. And then I have tan of 30 times 10. Now what's kind of nice with this one is I need to get the AB all by its lonesome. So I need to divide both sides by whatever it's multiplied by, but it's just multiplied by 1. So whenever I divide anything by 1, it is what it is. Oh, I wouldn't mind having that in. Okay. So then AB is tan of 30 times 10. So I'm going to get my trusty dusty calculator. I'm going to say tan of 30 times, oh, see, then it becomes a bracket thing, right? So I'm going to go like this, and I'm going to hit close bracket. Because otherwise it's going to be the tan of 30 times 10, so you're going to find the tan of 300. We don't want that. So we want to say times 10. There we go. And we get, oh, this is actually really nice troubleshooting, because I'm like, what? Negative? That's not supposed to happen yet. You're not supposed to see that until grade 11 pre-cal. Okay, but look at this. It's on rad, so I need to make sure that it's on degrees. Let's try this one again. There's nothing wrong with watching a teacher troubleshoot, because you might find yourself in that situation too. Close bracket times 10 equals, okay, there we go, 5.77. So we're going to go back here. Boop. Nope, not that one. The bottom one. There we go. So then I'm going to say AB equals 5.77 don't forget your units, centimeters. And that's your answer, so you can put a box around it. Okay, let's find the length of side FE. So instead, I'm going to change my color here. We got FE right here. Yep. There we go. So let's label this thing. So here's our angle. So FE is actually our adjacent. It's our beside side. Okay. And then DE is going to be our opposite. So I'm going to say tan. I'm not going to say tan of F because we know what that is, okay? We know the angle is 20 degrees equals opposite, which is 10, over adjacent, which is our FE, divided by 1. Okay, so now what we're going to do is we're going to do that cross multiplication again. Okay, so this one is going to look a little bit different because the FE is in the denominator. Okay, we're going to have to do one more step. So on this side, I'm going to say, with the green, I'm going to say it's going to be 1 times 10 equals FE times tan of 20. So we want to isolate the FE by itself. So what's kind of nice about when we multiply is we just divide both sides by whatever is multiplied by. So in this case, it's tan of 20. So I need to divide this guy also by tan of 20. So I'm going to put it into my when everything simplifies out, the tan of 20 cancels out. I have FE left on this side, and on this side I have 10 divided by tan of 20. Now I'm going to go to my calculator here, and I'm going to go 10 divided by the tan of 20. Hit equals. There we go. 27.474774. So we're just going to round it to 2 decimal places, which is 27.5. So then FE, it got a little squishy there, equals 27.5 centimeters. So you're going to note that there's a difference between example 1 with the unknown on top and example 2, the unknown on the bottom. Okay. So just set up your ratios and then isolate. Sometimes, like here, you won't have to isolate because it's multiplied by 1. Sometimes you will need to isolate, just like here. Okay, let's do a problem solve. So a searchlight beam shines vertically on a cloud at a horizontal distance of 250 meters from the searchlight. The angle between the ground and the line of sight to the cloud is 75 degrees. Determine the height of the cloud to the nearest meter. So thank goodness we have a visual here. I'm just going to expand it a little bit and make it, this is probably a more realistic picture, but this gives us a little bit more room to draw and breathe. So this guy right here is going to be 75 degrees. We know the horizontal distance from the searchlight is going to be 250. So this is where we're going to put that 250 meters. So we want to determine what the height is because our cloud is up here. So we want to find out what this guy is right here. So we're going to call that our H. Okay. I don't like that because that's like hypotenuse. We're going to call this one, we're just going to call it C. This is the height of that cloud. Okay, so first things first, let's identify what our opposite and adjacent is. So this one right here, this is our angle here. So our beside side, ADJ, is our 250. And our opposite, OPP, is our C. Okay, so let's set up our tan. So tan of 75 equals opposite, which is C, the height of the cloud, over the adjacent. Which is going to be our 250. Now remember, I'm going to put this over 1 so we can cross multiply. Woo! We got one where we don't have to divide out by the tan. So on this side, I'm going to say 250, and sometimes it's easier to write the number in front of the tan. So 250 times the tan of 75 equals C times 1. Now I don't have to divide or isolate out anything because we know anything divided by 1 is just itself. So our answer to C is just going to be 250 times the tan of 75. So 250 times the tan of 75 equals. It is 933.01 meters. So 933.01 meters. I'm going to put a box around it because I like getting marks for my teacher. Okay. Last but not least, last question here. Claire knows that the Calgary Tower is 191 meters high. At a certain point, the angle between the ground and Claire's line of sight to the top of the tower was 81 degrees. To the nearest meter, how far was Claire to the tower? Why is this distance only approximate? And we'll talk about that. So I'm just going to make it into like a little bit of an easier writing right angle triangle here. So I know that this is 191 meters, and I know that this guy right here is 81 degrees. So this one right here is going to be our opposite, because it is opposite that angle. It's the only side that doesn't help make that angle. And then this is the beside side. Okay, this is our ADJ, and I'm going to call it X this time. Woo! So we're gonna start off with saying, okay, so the tan of 81, because that's the angle that we begin at, and I'm just gonna go over 1 already because we know we need it, is going to be opposite, so 191 over X. So then we're gonna go multiply these guys together. So I have 1 times 191, and then equals X times tan of 81. So I'm going to divide tan of 81 on both sides. So that cancels out. I'm going to do something that I don't usually like doing, but I'm going to put an arrow right here because I didn't give myself enough room. So what's left on the right hand side is going to be our X. What's left on the left hand side is going to be 191 over tan of 81. And I'll get my calculator. 191 divided by tan of 81 equals 30.25 meters. So X is going to be 30.25 meters. Great, that's the answer. So let's talk about why it's approximate, because when we zoom into this little picture right here, it's not like her eyeballs are right on the ground, right? Like she's actually a person who has a height to her. So that's why it's only approximate, because really she's going from here, right? She's going here, and this is where the 81 is. Oh. Undo. Let's see if this is any better. Yes, okay. This is where the 81 is. So it's only approximate because it's not exactly from the ground. And we're going to do a little bit of a lab where you're going to build a tool that will help you estimate a few things. So it's kind of an exciting question to end on, because even though it's approximate now, we will find a way to make it not so approximate. Okay, this is your homework. Remember, sometimes we use Pythagoras, but you're old pros at that. Okay. Good luck with your homework.